program there. Formerly, I was a local official, a mayor of Indianapolis and deputy mayor of New York. First, the Ash Center, where we work, would like to acknowledge the land on which Harvard sits as the traditional territory of the Massachusetts people and a place which has long served as a site of meeting and exchange among nations. Today's event is being recorded and the video will be made available on the Ash Center YouTube channel. You're welcome to submit questions anytime throughout the duration of the event. We got some terrific questions in advance. Please send them via the Q&A button at the bottom of the screen instead of submitting them via the chat, if you would, please. Let me next introduce our panelists today. Betsy Gardner is a writer for Data Smart City Solutions. She's a producer of the Data Smart City podcast, has a master's in urban and regional policy from Northeastern. Jill Jamieson is one of the nation's experts on infrastructure and public-private partnerships. She's president and CEO of Illuminati Infrastructure Advisors and a distinguished senior fellow at the Global Resilience Institute at Northeastern University in Boston. She's a frequent author and keynote speaker on issues such as the ones we're talking about today, as well as public infrastructure funding, finance, and delivery. Luna Liu is the American Concrete Pavement Association professor at Purdue University. She's the founding director of the Center for Intelligent Infrastructure, and she leads an interdisciplinary group that works on novel nanomaterials and devices for energy harvesting and sensing applications. I told her she has to talk down to my level and when she presents, or at least translate after she goes through the scientific part. So we had a great panel, and I want to begin by asking Betsy to just summarize the paper, which kind of led to the panel on the importance of digital infrastructure as we think about the future of infrastructure. Another way to put this is how can we build infrastructure that doesn't look like your father's Oldsmobile? So Betsy.
Thanks, Steve. I'm just going to share my screen. All right, so thank you all for coming to our talk today. We're going to be diving deeper into our paper, our newest paper, Towards a Smart Future, Building Back Better with Intelligent Infrastructure. As Steve said, I'm just going to give a brief overview of our paper that Melissa has linked in the chat before we move to the Q&A session with co-author Jill Jamieson and subject matter expert Professor Luna Liu. This conversation is very timely. Right now, all eyes are on infrastructure. Tomorrow, there should be, hopefully will be, a vote on a massive infrastructure bill. And the vast majority of Americans, recent polls put it at over 80%, support infrastructure spending. So we know that the US needs to build better infrastructure, but we're making the case for building a system of connected, intelligent infrastructure, because otherwise we're going to be back in this same hole in the future. So in our paper, we first define intelligent infrastructure, and then we discuss its benefits, which include life cycle cost savings, enhanced safety and resiliency, better sustainability, and increased equity. To us, an intelligent infrastructure system is one that integrates digital technology, sensors, and data into the physical structures. It could be roads, bridges, sewer systems, sidewalks, anything like that, and then uses that information to identify issues earlier, build more climate resilient structures, and to guide equitable investments. So that last point for us is really crucial. Intelligent infrastructure systems incorporate equity in every step. Data and mapping have shown exactly where the previous investments in better, safer infrastructure has been built. And it's not in communities of color, it's not in Indian country, it's not in low-income areas. So this is a moment to actually address those issues and use data and smart infrastructure to detail how and where to invest and to hold ourselves accountable to those equity goals. We also do discuss and acknowledge the challenges to intelligent infrastructure, which mostly fall under things like the higher upfront cost, the fact that a lot of this technology is still evolving, and there are cybersecurity threats. These issues are addressed in our paper and the policy recommendations, which cover federal, state, and local governments. So we have recommendations for all levels because it's going to take all levels of government to achieve more equitable, sustainable, and intelligent infrastructure. Again, the full set of recommendations is in the paper, but just a few to keep in mind during this conversation are grants and incentives from the federal level, budgeting for smart infrastructure at the state level, and at the municipal level, investing in like comprehensive asset management systems, and then also training local employees and city workers on how to use them. So please do check out the full paper and also visit our site, Data Smart City Solutions, which I will link in the chat. We also have a podcast, the Data Smart City Pod, and this conversation will actually be on the pod next week as well. I'm going to hand it back to Professor Goldsmith to start the Q&A. And remember, if you have specific questions, please put them in the Q&A box.
Thank you, Betsy. I'm going to moderate the conversation, but I'll have an irresistible impulse to add my own views occasionally throughout the conversation. Jill, let me start with you. It feels to me like building physical infrastructure without digital infrastructure runs a substantial risk of waste, right? Or lack of resilience, or lack of dynamic adaptability, or reducing maintenance opportunities. But just without going through the whole list, if all that's true, at least I haven't heard much discussion of this subject in the debate about the infrastructure bill. Am I wrong? And if I'm right, why not? Why was smart infrastructure contemplated in the original bipartisan bill? And if not, why was it overlooked?
So, yeah, you're right. The Infrastructure Investment and Jobs Act, the IIJA, which is the bipartisan bill, really replicates all of the problems that brought us to where we stand today. There is a spattering of reference in their defense. There's a spattering of references to sensors and smart technologies, but it's very limited. It's V to I technology, vehicle to infrastructure technology, so very specific, or maybe wildfire sort of sensors. But there's not a writ large approach to, hey, let's invest in a more modernized infrastructure system. And so the United States is woefully dependent on what we call the repair and replacement mentality. So we are still investing. Most of our infrastructure, as we all know, was created generations ago. Depending on the sector, you might have some in the 60s and 70s, but there are water systems still in urban areas that were created during the Civil War. Abraham Lincoln takes credit for those. And the fact that they have not been upgraded and modernized in a whole-scale basis till today is really what's putting us into this sort of dire straits. So a couple of things about the IIJA. First of all, the amount of funding, about $1 trillion over an 8-year period, is not that much money, to be quite frank. Our infrastructure deficit of the nation is more along the lines of $7 trillion that we need invested by 2030 just to maintain sort of to tread water with GDP. So there's not a whole lot of money to go around. But on top of that, to your point, Steve, the investment itself is really focused on, here, we're going to throw some into bridges, throw some into transportation, with very little articulation of what it means to modernize and upgrade. It's about money, not about value. And I think that's where some of the where the rubber meets the road, they kind of missed the mark on that. It's not to say there's not some consideration of it. The word intelligent infrastructure is mentioned 7 times in 2,000 and 740 pages. So we did get 7 references. There is like a smart community resources center that has some money that'll go to sort of trying to invest in new technologies in this regard, but there's no linkage between the investment itself and doing these sorts of things. And I think that, there are objectives that are stated in the bill, which is to build back for once in a generation. To your point, how do we build back now when we're reinvesting in Jurassic area methods and materials? And on top of that, how can we build in a way that we can prevent ourselves in 20, 30 years being in this exact same situation with a backlog of deferred maintenance, with no real strategic plan for mapping this forward? And so, yeah, in my view, they did somewhat miss the mark on this. That's not to say that it needed to be legislated. There's still opportunities, I think, as this bill rolls out for the implementation to try to incorporate a little bit more in terms of smart infrastructure. And hopefully this conversation today in the paper will help to inform how that might happen.
Thanks, Jill. Let me pick up on a couple of themes, maybe go to Luna. Luna, if we think about, Well, just to express kind of my own bias, there's not much
Sure.
conversation at the local level about the life cycle costing of infrastructure. You know, like Jill's build and then replace, right? And
Mhm.
you know, repave or seal the cracks or whatever the case may be. So you really are one of the nation's leading experts on intelligent infrastructure. So how would one utilize intelligent infrastructure in order to address this deferred maintenance, or to build in a way to begin with, whether it's materials or sensors, that allows us to kind of preemptively address maintenance going forward?
Thanks, Steve. That's a very important question. How can we use the intelligent infrastructure to address the maintenance issue? I think there is a couple of levels we can look at. First, we can use all the data has been collected. So first, what is the intelligent infrastructure? Maybe we can break down for a second. As Betsy has mentioned, it really is using the IoT sensors and the digital technology to provide a sustainability and the resilience and improve the quality of the life, right? So therefore, there is a tremendous amount of the real-time data which can provide a better information about infrastructure at any given moment. This can help us at several levels. First, we can prioritize the maintenance schedule, right? So therefore, we're not doing just going back every 6 months of patching. You know, people in Indiana always joke there's 2 seasons in Indiana. One, it's the winter season, another is the construction season, right? I think that's pretty much similar to every wells in the most of the country. As Jill mentioned, most of the infrastructure has been building about 50, 60 years ago. This is a maintenance season, right? So second is we can really drastically reduce the maintenance cost, and not only prioritize, but also reduce the maintenance cost. One important point Steve has bring it up is life cycle cost, right? So if we're looking at it from life cycle cost perspective, if the road condition drop from, you know, the drop from fair to the very poor, what happens is you have to double, not only double, triple, maybe spend 4 or 5 times more money to maintain that particular road. Right, so therefore we can immediately identify where is needed, and then from life cycle perspective, reduce the cost. And another thing, it's very important for us to think about it, as Jill mentioned, how can we develop a new policy to prevent the poor maintenance as what will happen today, right? So many decisions has been centralized making. I'm using the transportation as example because as a civil infrastructure professor, I deal with bridges and pavement all the time. There may be not be knowing to the public when the opening the traffic, for instance, if a major interstate going through the renovation, and when we should open traffic to the public, actually is determined by the very high level, not on the job site, not on the construction site immediately. It's arbitrarily determined at the high level based on the experiments and the historical data. So as such, is leading to a drastically traffic congestions, right? When concrete already reached the strength to able to bearing the load of the traffic, we're still not holding the traffic. So that's caused a tremendous congestion and the waste of the taxpayers' dollar, time, money, and the resources. So by using the decentralized technology, we can make in the better policy. And also we can encourage and promoting adoption of the new technology. Yeah, one thing I would like to use, for example, Purdue University has been working with Indiana DOT since 2019. We implementing smart road sensors in the 3 interstates. And then this preliminary data has been showing we improved 30% of the construction productivity and reduced 20% of the labor cost and the related insurance, and also reduced 15% of the overuse of material, right? So therefore, there is a tremendous economic and economics benefits can be regained from this.
Have you published? Is there a place where we can see that, or is that not? Is that not yet published?
We have published a paper on this at the American Concrete Institute
Okay.
journal, and I can share the link of the
That'd be
paper
great,
from
yeah.
our preliminary study. And also this project has been actually awarded by American Society of Civil Engineering at 2021 Game Changer Award. So I can share that link as well.
That'd be great. I want to get back to both of you kind of on, in particular, Jill, on what specific policy or legislative changes would be needed to kind of mainstream digital infrastructure. But I want to touch on a couple of subjects first. One is resilience and sustainability, climate, and the other is equity. And then we'll go back to the policy stuff. So Jill, back to you, and then Betsy, I'm gonna call on you on equity, but I'm gonna do the other two presenters on these subjects. So resilient infrastructure and infrastructure resilience are important topics. So how would intelligent civil works help the nation in terms of climate resilience? Jill, you're really one of the country's leading experts on kind of water and dams and the like. So how would you think about intelligent infrastructure and that side? And then Luna, let's go to you and think about what are policies or structures that need to be in place in order to accomplish these digital solutions that would affect climate. Also, I think your work on materials is really fascinating, and I think everyone needs to hear about that. But first, Jill, infrastructure resilience and resilient infrastructure, please.
Yeah, I think you just called me by accident a damn expert, right? So that's I'm going to take that and just run with it. But yeah, they're two separate things, obviously. So we have resilient infrastructure, and then we have infrastructure resilience, right? And I can give one example that covers both, and that's in the sort of the dam and levee area, right? So I think smart sensors in general and intelligent infrastructure are being rolled out on a piecemeal basis, to be quite frank, for a lot of resilience projects. And I think in the paper we talk about Hampton Roads area and some of the sensors are using for flood inundation and trying to be predictive in terms of where climate resilience and being able to evacuate people, et cetera. So that's one example, but probably one that I'm perplexed by why this isn't a thing yet, is in the dam and levee areas in the United States. So many people don't realize that we have in the United States something along the lines of 91,000 dams across the country, and the average life of those is average age of those is something like 57 years, which makes them older than me, which makes me feel good about myself, but not good about our safety as a nation. On the flip side, we have over 100,000 miles of levees. To be quite frank, we have not even mapped all the levees in the United States. Now, when these were first introduced in the United States, many of them were in rural areas. They were for farm purposes, water supply, et cetera. Demographic changes, population growth has made it so that now they're in metropolitan areas. Failure of these dams caused property loss, and we've seen it in Michigan, we've seen it in other places, right? So we have all of these dams and levees. 65% of our dams are owned by private entities, so they're not even government controlled, right? So we have this entire issue out there. And right now, our monitoring system for dams and levees is essentially a guy goes out every 5 years and kicks the dirt to see if they're okay. There's not a lot of money in the dam safety programs, et cetera. So this is an area where USDA and in some of our rural dams, they've rolled out a system that's already underway, which is the Smart Dam Sensor, or Dam Smart is what it's called. And basically, it's a series of sensors and intelligent infrastructure that will alert you to structural failures before they come along. I think if we're looking at policy, and I know we're not there yet, this is one of those things. Why would the federal government ever give money to the National Inventory of Dams if they didn't insist on some sort of more timely, cost-effective manner of monitoring those dams? So as we build them and going forward, it's something that could easily be put into an integrated system that will help not only in terms of the resilience of our cities, because a lot of this is flood protection and climate resilience, but also the resilience of our infrastructure, right? So we will know in advance if something starts to go wrong. In Europe, we're seeing it writ large. All of the dams that are being built now are including sensors, vibration technology, so that there's an opportunity to prevent preventively intervene if there are any sort of issues. And I think, that's just a really easy example for people to understand. But the truth of the matter, it is not normalized in the dam sector, where we're seeing a little bit more of this in transportation. You might have some fits and starts in the water sector elsewhere. This is an area that I think is still pretty wide open in terms of, the Army Corps of Engineers is an example. That should be part of their building standards going forward, to require this sort of things. To Luna's point, it saves you money on the life cycle side, of course, but it can also save you money in terms of the construction side by making sure that you build it right. So I think from a resilience perspective, and I could also speak to sustainability, but I'll let Luna do that. But on sustainability, I'll just say one thing. We've seen it work for water. We've seen it work in terms of water conservation on the supply side. If you have a smart pipe system, like DC Water has intelligent pipes and those sorts of things with sensors in there to see where there's leaks, in California and elsewhere, they can monitor where their pipe systems are starting to leak water. We lose in the United States over 16% of our drinking water on a daily basis. That's absurd, particularly in those areas that we have water shortages. On the flip side, where we have plenty of water and we have floods, I've talked about dams, and where we have bad water, contaminated water, as we all know, the use of intelligent sensors and whatnot can monitor water in real time, so that there can be anonymous data that can indicate where investments need to go in a timely manner to address those sorts of things. So I'll defer to Luna, who's much smarter than me, to talk about those same issues.
Yeah, that was an interesting set of facts, though, about how much water leaks. The same is true about waste in the wastewater system that could be, or CSO overflows that could be monitored and diverted. There's just so much opportunity in water. Luna, another way to think about sustainability and resilience, obviously, is, black hot asphalt is not good for the earth. And I know you're doing a lot of research on building materials. So tell us a little bit about that sense of resiliency and sustainability, please.
Sure, absolutely. So as Steve and Jill talk about it, construction and building industry, I think it's one of the largest contributor from the GDP perspective. And also, if you think about it, the vulnerability and the resilience, I think, construction building materials, it has a lot of role to play. For instance, the concrete is very, very brittle material, right? It's very strong, however, it's very brittle. And we heard a lot about recent, even the dam collapse in Michigan, right? And the condo collapse in Florida. It's all due to the very brittleness about the concrete material. So if we think about next generation, about material, how to improve sustainability and reduce and improve resilience, we need to think about how can we building the better material, right? A couple of examples I can be giving. It's happening in the research community and also in the private industry is the innovation in the materials. For instance, building flexible concrete pavement, right? So I don't know if I can share a very quick slides here. Okay, yeah, so here, there's some slides I would like to share very quickly. As you can see, can we see the slides?
Yes.
So, sorry, just to go in 1 minute. This is a traditional concrete under the loading. As you can see, it's very brittle. So a concrete with what we call the ductility, self-healing cementitious concrete by using nanoparticles. And what we can happen is we can build a very high ductility. And we go through the same loading condition at the same loading speed and same weight. As we can see, concrete can bend almost to 30 to 35 degree angle, right? So this is tremendous ductility has been added in the concrete, and this will give a better protection for the civilians using this. However, inevitably there is a crack. So what we can do is in the research and private community, the people actually building what we call the self-healing concrete. For instance, this is the research that has been happening at Purdue, we have pre-cracked concrete, and then after 8 days, as you can see, they're fully sealed, right? So this will be tremendously reduce your maintenance cost. We don't have to go back every 6 months to fix the potholes, and that will lead into the corrosion and other issues. And also, I know the carbon emission has always been a bigger concern because the concrete and the cement, as the largest material used in the world, we are contributing to a large amount of CO2 production. However, currently in our community, there is a tremendous research amount of work. Even the private company has been commercialized some technology called a carbon cure that can secure the CO2 and go through what we call the carbonation, can build a better and more resilient concrete infrastructure.
Hey, Luna, it's really very interesting. I'm actually bewildered a little bit why there's not more use of more incorporation of digital infrastructure / IoT / sensors in the concrete to send notices, or even in the asphalt, of micro cracks or changes in pH level or corrosion. I mean, so I know it would cost a little more to build that way, but the savings over time would be, I'll make up a number, 10 to 1 or 100 to 1 or 1,000 to 1. So am I exaggerating in terms of the importance of putting sensors into new construction or bridges that would send signals about vibration? Tell us a little bit about why there's not more of that.
Oh, I think you're absolutely correct. I think this is a very important thing. We should look into it. However, there is a tremendous barriers on this. One of the barrier, as you mentioned, the cost, right? Construction is very large volume. So unless we can make the sensor very cost effectively, not only detect signal, but also transmitting the signal, connecting the data, storage data, transmitting the data wirelessly. People do not like to use the technology if they have to put more work, right? They just want to deploy the sensor and leave there. So building the sensor cost effective, that's number one. Number two is, if you think about civil engineering, by training, we're very conservative and risk adverse. I think this is actually a good thing because we do need, buildings of bridges and dam has a tremendous effect, right, on the safety factor. So unfortunately, that also play a negative role when you're taking the new technology. So there is a more vetting process going through on that. And the second and the third part, I think, is construction, particular in the construction and civil industry, about adopting the technology. We need a higher skill sets of laborers, and we see that's the big challenge in the industry as well, right? The people just do not like to use a high tech if we're not making the high tech so simple enough and cost effectively enough. But I do see the trend in the industry to moving towards that direction. And for instance, we talk a little bit about Indiana DOT has been partnered with Purdue University, taking the sensor in the road. And not only that, Federal Highway is also partnered with us. And we have 7-8 other states has been signed up and in the piloting process and adopting the technology. So I do see the trend is going upside, but it takes time.
We've got dozens of questions, both from me and from the audience. I'm weaving them into my questions to you all, and we'll definitely run out of time. There's one that just came in. I don't want to mess up the flow because I got questions for Betsy and Jill, but the U.S. is not necessarily, or even at all, the leader in this. I mean, there's a question about the Dutch. We all know the Singapore story. I mean, what countries might, Jill, Luna, American policymakers, leaders look to as exemplars here?
Luna, do you want to start or do you want me to start?
You can start, I can add.
Okay. Yeah, no, I think that's a fair question, right? I mean, it's as I mentioned before, in Europe, for instance, in the dam safety, the Dutch have been very much in the forefront of a lot of what's going on in terms of those infrastructure. It's generalized. I think in the United States, to Luna's point about the reluctance to integrate this comes, I think, in part because we have a very decentralized system, right? So if you look at the European model, you've got a minister of infrastructure, and he can make these sorts of decisions on sort of almost a policy. We are a very decentralized country. And so you've got some decisions being made at the local level, some at the state level, and some at the national level. And what that leads to is inefficiency in decision making. So if we look at the bridge sector, where we know 67% of our bridge are in dire conditions at this point in time, it wasn't until the bridge in Minneapolis collapsed and we had the St. Anthony's replacing it, that there was really the first sort of approach in the United States to use bridge sensors, that can monitor vibrations and those sorts of things. Since then, we've seen it take off a little bit more across the bridge sector because of the demonstration effect. But I think, the work that Luna's doing in Indiana, for instance, that's going to help inform other jurisdictions. The challenge we have, and this is where I think the federal government infrastructure bill kind of swung and missed, is that you kind of do need this centralized leadership to say, look, I'm going to invest money in the technologies because we need smart sensors that can, you can't have battery technology when you've got them in pavements, right? We've got to improve the technologies. We've got to have the Internet of Things connectivity. But I think that's one of the challenges we have in the United States. And it's not just in this, it's in everything we do. Because we are very decentralized and because we are very jurisdictionally driven, we sometimes miss out on trends or we're a little bit late getting to them.
Lots more questions, and I want to get to that one that John just asked everyone. But Betsy, really quickly, before we get to equity, we did that interview with Georgia's chief traffic engineer, and I was thinking about another definition of sustainability is how to, and this came up in one of the questions from one of the audience members, is how do we use existing right-of-way better? What does asset management actually mean? It surely means more than just filling a pothole. And Betsy, could you just summarize, have you put that article up? Is it a podcast yet or an article? And could you, with the partnership between Georgia and the nonprofit, the Ray, to do EV charging stations and solar around right-of-ways was really very fascinating, I thought.
I can find that article, definitely. And I think I know we're not talking about equity yet, but I think all of these are still also examples. Like any sustainability work is going to end up being equity work because all the research shows the people who are going to be most impacted by like climate events, disasters, things like that are going to be in communities of color. So I'll look for that and I'll add it to the chat. And I think that really just kind of like all ties in to like how sustainability and equity are both so crucial to any kind of intelligent infrastructure.
So if you thought about equity, Betsy, and I know you've written on Data Smart about this maybe more than anybody in the country, but so you could think about equity in visualizing where current infrastructure investments are. Obviously, that would show the inequity of the current infrastructure. One could think about equity in improving community participation in where infrastructure development will occur, right? So you're visualizing it. Or you could think about equity and digital infrastructure as how you would build in sensors that would alert policymakers to the disproportionate burdens of folks in challenged neighborhoods, think air or water. Do you just want to kind of give us a couple examples from your writing that might be interesting?
Definitely. One of the things we talked about in our paper is the fact that air pollution more negatively impacts Black and Hispanic communities than they actually produce. So more of that air pollution is being produced in predominantly white areas, and it's negatively impacting in communities of color. And there are examples I wrote about in the paper of cities that have used sensor technology to literally show that these negative health outcomes from air pollution are unfairly impacting, and then making changes, particularly in things like mobility and transportation, to try to alleviate a lot of that like inequitable burden. In Oakland as well, and I can share this link in the chat, In Oakland, they have a Department of Race and Equity, and that worked with their DOT to do a huge paving project called the Great Pave. Essentially, they were able to divide up the city and look into what areas had and hadn't been invested in. And they found that a lot of the non-white communities have been neglected for a very long time in terms of their quality of their streets, so for their paving, and then also in the safety of their streets, particularly as it related to like protected bike lanes and safe areas for biking. So they did essentially a computation to say, like, where have we not been investing and what are the road conditions? And then they overlaid that with census data and ACS data that showed that those areas were much more likely to be communities of color. And they used all of this data. They put together a whole slideshow to show folks in the city, to show residents where they were going to be investing almost $100 million in these local street pavings. And so not only did they end up being able to prove that these areas needed attention, but they were very easily able to convince everyone that these areas should be prioritized for paving. And then as kind of like a secondary benefit, a lot of the folks in those communities really didn't believe that the city was going to come in and pave. They felt like they'd kind of heard it before and there just wasn't a level of trust there. So when they did go in and they showed that they were valuing and recognizing that those areas had been neglected and addressing that issue, then it built a lot of trust between those communities and the city. So I'll share those things in the chat.
You know, I'm going to call on Jill and then Luna on the same subject, but there's all sorts of things that are kind of interesting that you don't focus on. Like there are curb and sidewalk platforms now that will analyze the data for where the scooters are placed or cost of parking. And, you know, we have many of our cities actually subsidize parking in the wealthier areas, think commercial, where they could actually, if they did sensors and dynamic pricing, they could do a couple things. They could help direct cars to open parking and save emissions, A, and B, they could generate more revenue in, you know, high commercial areas and redistribute that revenue to resolve transit desert problems, right? So we don't think about connecting A and B. Jill, you watch this issue as well as Luna. Let me call on you and then Luna next, please, on the equity issue.
Yeah, I mean, I think that Betsy articulated very well. I mean, for somebody who works sort of at the intersection of infrastructure and policy, there's a reality that you just have to acknowledge in the United States, and that is money talks, right? And no matter what the definition is of how budgets are prioritized, it all comes down to who's got the most influence at the moment, who's complaining the loudest, right? So you know, at the federal level, they might do a benefit cost analysis. But those are only, you know, it's the go-go. It's only as good as the inputs are, the outputs are only as good as the inputs, right? And so there's a lot of lobbying that goes on around where infrastructure investment should go. There's a lot of, you know, hand-wringing. Politicians will take it also in terms of constituencies. Where am I going to get the votes? One of the things I really like about, you know, intelligent infrastructure, smart sensors, is it gives you anonymized data. It gives you something that nobody is influencing from a political standing in terms of what is our most urgent need now. And I think, to be quite frank, we need that at the federal, state, and local. I get that politicians may recoil a bit from that because it leaves a little of the discretionality out of it. But if we really want to promote equity, then I think that's something that we need to do. And maybe, again, when you're looking at federal, state, and local funding opportunities, maybe there's a scorecard for the anonymized data that can be influenced in the budget decision-making process. But I just think that we're never going to get around this problem as long as the human subjectivity is involved in it, right? And we're getting better. And I get it. We're all scared of the machines taking over the world. But there is something beneficial in having good real-time data. So often we see in poorer communities, you know, the lack of investment, bridges that fall down are usually in their areas. It's not, you know, where the wealthy are going to play golf. And so I think that, you know, having that prioritization, incorporating that, regularizing it is going to be really important in moving forward. And you can't do that without intelligent infrastructure.
Yeah, the same would be true, I think, of, always thought that the Chicago array of things, IoT's air sensors, were critically important. There's, you know, we know that the social and health harms done to distressed neighborhoods. And if we measured the air, we could preemptively affect asthma rates or, you know, or think about all the harm, not just from lead pipes, but lead pipes, lead soil, lead, doing analytics for lead paint. Luna, what observations do you have?
I think both you and Jill has raised a very important points. The most of the equity or most of the damaged infrastructure or air quality or anything needs to be repaired actually happen in the rural area. Right? Jill has mentioned about bridges, a lot of bridges, the 16% of the bridges are in obsolete conditions. And if you think about most of them actually located in the rural area, what makes it worse if we think about it? Most of agriculture and the manufacture is located in this area. So the big semi trucks that has to go through it, and there is no even weighing station on this road, right? The weighing station is in interstates. So how those semi trucks rotated to there is all arbitrarily determined by somebody at some point, right? By historical data. Again, 50 years ago we built these bridges, we still thinking the strength of the bridges, so and so. So this is the important thing we need to think about and address. And I think particularly concerning us is with autonomous vehicle coming in, we talk about the truck platooning, everything is rely on, the broader band and the 5G connectivity, and how we're address that in the rural community. That's another issue we really need to think about it and maybe add it in the bill.
We have a lot of issues left. We have governance issues, we have privacy issues, we have security issues, we have P3 questions. Let me set up the governance and talent issue that John in the chat and other people in their submitted questions. So let me just real quickly start with a story that'll appear to be irrelevant. I don't think it is. So when I was deputy mayor of operations for Mayor Bloomberg, before I got there, they had done maybe the world's best long-term sustainability project, right? They had a plan NYC. There was sustainability opportunities in every department. That's good, but what was even better is there was a long-term sustainability office. This job was to make sure that the agencies of jurisdiction actually paid attention to what was in the plan. And Jill, was a little bit the same thing I saw, that where agencies would present, I was deputy mayor of operations, they present their construction projects. I see you'd say, have you value engineered this? And they'd say yes. But the yes was pretty haphazard, casual yes. And so a centralized like value engineering czar in the OMB then would always find 10 or 15% more savings. So as we think about this issue of kind of governance of digital infrastructure, maybe Jill and then Luna, it feels to me like these issues are horizontal issues, but the agencies are vertical issues and the skill sets are different, right? So both, I'm going to ask Jill how you would, I know you're a little bit more of a, well, you're a federal and local expert. How would you think about the governance issue? And then I'm going to ask Luna, where do you get the tech talent, right? Some of it could be from the private sector, but some of it has to be in-house as well. So first, Jill, how do we get from here to there? And then Luna on the tech skills.
Well, I'll start with an example of what not to do. I don't know that we've actually found out exactly what the best methodology is, but because we are, to your point, very diversified in terms of our jurisdictions, even within a city or a state government, right? So you've got your DOT, you've got your water authority, you've got your port authority, you've got, Department of Planning, et cetera. And each of them, they're their own stovepipe, right? And so we've seen this in resilience, just in general, for flood, climate change. So we know that a levee is only as good as its weakest point, but if you need a geographic levee that's going across that, some of it is in the airport, some of it is in a private property that's going to be developed in the future. We have not successfully as a nation been able to figure out how do we coordinate across jurisdictions. You may have a resiliency officer, but to your point, Steve, they don't have the teeth or the power to be able to do that. And so I think that we need to start really revisiting how we're doing things. And maybe it is, you've got your CIOs, you've got your chief information officers now that are usually focused on the Internet of Things, but maybe they need an office within there that's also on the integration. Because to your point, Steve, we have to look at infrastructure as a system. If our roads and bridges are failing, then our waterway is going to be able to accommodate some of that, right? And so there's this real-time sort of, it's a web of systems that need to be able to work together in real time. And that's outside of any office that exists today. I don't think it should be in an OMB because I don't think it's just a budget issue. I think it's a service and performance issue. And where that's going to reside at a jurisdictional level, I think is TBD. I don't think any city or any state or any federal agency has figured that out yet. But it may be the need for the creation of something that's a little bit different than what exists today.
Yeah, that was a great answer. So, Luna, it just seems to me that the opportunities are immense. For example, if you said we want to reduce particulate and CO2 emissions, then if you took the sensor data in every intersection in a city and you wanted to reduce queuing, which, why cars and trucks are stopped at lights, or we had a question about right turns and pedestrian safety, right? So you can take anonymized data if you had the right science, right, the right technology, and you could tinker with those in order to smooth traffic or improve safety. It wouldn't be that difficult. But those talents don't reside in most cities around the world, and very few of any U.S. cities. Now, you could have, I'm going to go back to Jill after you give your answer, because you could think about structuring a public-private partnership where there's a managed shared services, but they have to be managed by somebody who's inside. So first, Luna, how do you think about the technical skills? And then maybe back to Jill on give you an opportunity to make a couple comments on public-private partnerships. So we have like 5 questions about that as well. Luna?
Yeah, so Steve, I think you raised a very important point. By using the IoT sensor, we can achieve mobility, safety, sustainability, and resilience at the same time, right? So I don't know if I have an answer where we can get a tech talent. So there is very difficult. It's challenging. It's not only in the United States, globally, but I think fundamentally, as an educator, a professor in a university, I think fundamentally we need to think about it, how we restructure the education system, and particularly at the higher level. If you think about a current civil infrastructure, civil engineer, not only with the digital technology, we're not only interact with buildings, the structures, but also with the sensors, hardwares, right, embedded systems, IoT communications. So therefore, in the education system, we really need to educate the students which exposed to this digital technology, right? Not only just the internet connectivity, but also on the hardware and software part. I think they need at least to be able to carry the same language in the job site and then, communicate with each other from education standpoint. And I think that's an important thing. I mean, we need to really think about it.
Jill, you consult with a lot of companies on public-private partnerships, more often in construction, but also in maintenance, right? So just hypothetically, how would we think about, and there's plenty of ways to do a P3 badly, and there's some ways to do, so without kind of going, we don't have enough time for you to give us a lesson on that, but how would you think about the utilization of the private sector in the digital infrastructure space, specifically as it relates to the management of the data that would flow from the IoT, the algorithms, or how to put that together in the right way?
I think it's a logical first step, right? To Luna's point, we've got workforce issues outside of technology in the construction industry. We've had shortages for years. That's not going away. The Infrastructure Investment and Jobs Act, the jobs part, it has a lot of workforce training associated with it, but really not in this area. And so in the short term, I think we're going to have a workforce shortage in this area. So where do you look when you have sort of a public sector workforce shortage? Very easily, you can look to the private sector. Now, have they done this at scale in terms of heavy civil engineering? No. But I think we can look to the example of public or buildings, commercial buildings, right? So we now have smart buildings up and down the chain. People are managing them through centralized management systems. They're getting smarter, more technologically advanced. They're working in those areas. It's the same model. Yes, there are differences. And I think that, you could have a company come in under a global public-private partnership. It wouldn't be too difficult to structure, where they could really just advise maybe on some of the inputs. But to your point, Steve, on terms of the outputs and the management of of the data, how to synthesize that data and prioritize it and those sorts of things. I think it's very much within the private sector's purview, at least until they can get the public sector up and ready to do that themselves, right? But I think that we need to partner. It's all hands on deck at this point. I don't think you need to think of yourself as public or private. I think at this point, it's how can we achieve the outcome? And I don't think that the private sector should be ignored in this particular instance.
I think I've touched many of the questions. We got about 10 minutes left. I want to do, this sounds ridiculous. I want to do 5 minutes on privacy and security and 5 minutes on how to change federal and local policies to accomplish this. I have Luna do one and Jill do the other. So Luna, I was at the computer show in Las Vegas about 3 years ago, and an Israeli company showed me, they were providing security packages, but they showed me, I don't remember what it was, like 25 ways you could hack the connectivity of a vehicle, right? All of which were horribly scary, right? They weren't like a little bit scary, they're like horribly scary. So privacy and security, obviously different issues, but just a couple quick questions about how our audience, where they would go to get smarter, or you're just kind of overview policy questions on that issue, recognizing that the issue is worth its own hour, but I don't want to omit it altogether. That wouldn't be right either.
Yeah, I think when you talk about cyber attack, this is definitely a very critical challenge confronting the society. If you're looking at it, because the cyberspace, even the cyber infrastructure is very, very complex system that including your computer, your sensor, your hardware, your software, your network, your data, where you store the data. So any parts can be attacked, right? So there is a lot, by nature, it has a lot of vulnerability. So, you know, there is no way anybody can ensure 100% of cybersecurity, but we can definitely improve it by using, you know, new modern technology such as, you know, AI-based cybersecurity, authentication, you know, verification, validation, even decentralized sensor system. I want to give an example when you talk about it, how when autonomous vehicle come in the road, how you can cyber attack your vehicle, right? So what if one vehicle is driving maliciously or cyber attacked maliciously in all autonomous vehicle? And currently, we only have a vehicle to infrastructure or vehicle to vehicle communication. Another thing we need to think about it is there cost effectively localized the sensor that can quickly identify this malicious driven behavior of the vehicle that can quickly send it a signal or alert the system, right? Not only localizedly, but also to the system wide. And I think that is another important technology we need to look at, not just to rely on the vehicle itself, right? So because as we talk about, there is no way you can 100% ensure. And yeah, of course, the better funding, right? And investment in the research development in this type of the related cybersecurity technology is important.
So Jill, I want you to talk, if you would, close a little bit on policy and legislative change. Let me note that just because it's also an hour, that the privacy issues are real, that a city or a state using digital infrastructure should have explicit and transparent privacy principles. They should be doing privacy audits. They should be using anonymous data. It's a huge issue that deserves attention. That I don't think we, Betsy and I did an article on you know, why we shouldn't insist on dumb cities instead of smart cities just because of privacy and security. So just wanted to note that we have some stuff up on our site about that. But Jill, we have this big debate in Washington, and there's going to be money in one way or another and go flowing out to the states and cities, and there's money being spent in the states and cities now. What policy or legislative changes at the state or federal level are needed to accomplish the things we've talked about for the last hour?
Well, I think let's start at the federal level. You know, I think that we have the Infrastructure Investment and Jobs Act, which seems to be the blueprint for what's going to go forward, obviously with some changes. To the issue of cybersecurity, that is heavily talked about within the bill, but really limited to the power sector. For some reason, like the ideas don't cross over from sectors. They're very sector specific, which is a little bit of a disappointment. But that said, you know, legislation is a first step in the implementation of any programs and policies. And so, as I said before, I think that there is still opportunity when implementing this legislation to put in implementing guidelines that would align with what we're talking about. So, for instance, when you're talking about federal grants or loan programs like WIFIA or TIFIA, put in as one of the conditions of getting that federal money a certain level of commitment to smarter technologies, right? Now, what that looks like exactly, to Luna's point, we can't ask people to invest in bleeding edge technology that hasn't been proven, but there's a difference between forward looking and backward looking, and to that extent, some level of that. And so, in the United States, when you want a federal loan or a federal grant, you have to abide by certain requirements. The Davis-Bacon Act, Buy American Act, American Steel Act. Add another line, and that line should be related to this. That's not that hard to do. I think it would foster American innovation in this as well, because the sector itself would then see itself as being more relevant, et cetera. So I think that's one area. Another, I think at the federal level, would be interesting to have a cross-sector SEP, which is a special experimental program. And within that, try to get investment into maybe some multi-sector projects or programs where we could link, as we talked about before, bridges and roads and highway systems, et cetera, through the use of smart infrastructure to see how it works, right? See where the cybersecurity vulnerabilities are, et cetera. But that can be done under a SEP program, and that's not a lot of money, so that's easy enough as well. And then I think in sector-specific areas, as I mentioned before, look, we have a new program that's been funded. They're just rolling out the implementation guidelines. But if we look at like the Corps of Engineers with all of the dam work that they do, that's DAM, not DAMN, work that they do, having them or incentivizing them to use dam smart programs and those sorts of things, so that in the next 50 to 100 years we have real-time information about the status of these dams, I think is pretty easy to do. State and local governments, I think to your point earlier, Steve, it's really kind of changing the way they do their budgeting. Having them look more at the life cycle cost. So one of the things we did like in the Infrastructure Investment and Jobs Act is there's a lot of references to public-private partnerships, but to life cycle asset management as well, right? And I think the life cycle asset management, look at the life cycle cost of this as opposed to first costs. We know that first costs might be more expensive if you're using this sort of technology, but when you look at it over the life cycle, you're going to be saving costs. You're going to, is again, the St. Anthony's Bridge, very good example. It was 0.1% of the total cost to put in the bridge sensors, and it saved them countless millions of dollars in terms of repairs and those sorts of things. So I think that there's a lot that can be done, but it's really normalizing this and also getting the information out. I mean, you've got groups like Luna's team who's doing some great projects and programs, but that really has not been dispersed to a national level. And having somebody sort of promoting that, I think, is going to be very important to the nation adopting this on a larger level.
That was great. Yeah, it seems obvious, at least to me, that by not insisting on digital infrastructure, we're giving away sustainability accomplishments. We're giving away safety accomplishments. We're actually wasting money over life cycle costing. And to not insist on it is an admission that we are not serious about those issues. So we've used our hour. I first want to thank the ASH team, Melissa, Julianne, and Caitlin for making this possible, and to Betsy, Luna, and Jill for just a terrific set of answers. And your expertise is great. And when we'll have another one of these that lasts 6 hours, and each one of you can have 2 hours to talk each. So it's a great session. Thank you very much for your time, and we are adjourned.